Okay, you could do that exact same algorithm with a repeat. Repeat is the same sort of control structure. It tests the condition, and if it's true, it skips. No, it's the other way around. Notice we've reversed them. Here we're testing if t is less than 2. Here we're testing if t is greater than 1. So it tests it, and if it's false, it'll do this. Otherwise, it breaks. So these only get executed when t is 2 or more. And that's what the break does. The break causes it to go back. So repeat does the same thing, only it's the reverse logic, which always gets me confused. Instead of being true, it only does the body. It only executes the statements in the body of the repeat if the condition is false. And so if we could create a function out of that, and fact3, and then if we call it with the exact same vector as an argument, we're going to get the exact same return that we got for this one, because they do the same thing. Okay, so that's another control structure. Let's look at a couple of things. Let's look at another useful function. When you're writing functions, you'll note that if you have a very large data set, and we'll see some of this pretty soon, you'll see a little stop sign. If you're using RStudio, and you'll see a little stop sign that will appear right here, which means it's thinking. It's doing it, but it's taking a while. When the stop sign is there, so the red hexagonal sign says stop. When the stop sign is there, you can't use any of the controls. You just have to wait for the processor to free up. Well, the reason some functions take a while, they're varied reasons, but you can track that. There's a function in R called systemtime that will return at least 3 different parameters: the time that the function takes, the time that the system, the time that everything takes. Let me show you. It shows you for the function, it shows you for the user, and it shows you for everything. Here, okay, so here we're going to use RUnif. R is one of those pseudo-random number generator functions. Note we're making a very big vector. This vector has 10 million elements, and it's uniformly distributed. Okay, so X, note how quickly it executes. No problem. This is a vectorized function. X contains 10 million elements. It only will print 10,000 unless you change it. Here are the first 10,000. But now, and they're random. They're uniformly distributed, but they're random. They're pseudo-random. So now we're going to run the max function on X to find the largest. That's what max does. Max is vectorized, so it's pretty fast. But it's got to go through 10 million of them and just pick out the one that's the largest value. Okay, well, let's keep track of how long it takes to do that. It's pretty fast, really, because it's vectorized. So if I crank it up here on my machine, and I call this machine the Screamer, because it's very, even for a Windows machine, it's very fast. It has 8 gigabytes of RAM, and it's a 64-bit machine. It's pretty fast. It took, for the program, 0.06 seconds, and for the system as a whole, and I don't have any other programs really running other than the operating system, almost the same amount of time.